Number 3, in general, how do periodic properties of the D block elements compare with those of the main group elements? Right? One of your goals for this section is to compare main group element properties with D group element properties, and it kind of is a little bit simple in idea, but not super intuitive. The reality is that they vary less. Okay, D block elements have a smaller amount of variation in their properties than do the main group elements. And you can tell because when you compare two elements in the transition metals, the D block, you see that they're all pretty darn similar. They're not exactly the same, but when you look at iron and copper, they're pretty similar. When you look at nickel and zinc, they're pretty similar. If you look at chromium and titanium, they're fairly similar. Again, not identical, but they are pretty similar. They pretty closely share those characteristics. And so there's little variation in properties among D block elements. If we look over at the P block elements, we see quite a bit of variation. For example, if we look at period 3 and start with aluminum, okay, P block, aluminum, that's a good old metal. Okay, it's shiny, pretty high luster, it's a good conductor of heat and electricity. And then when we go over just one group, and we're looking at silicon, silicon is a semiconductor. Okay, it's not a metal, it's a metalloid. It's a semiconductor. It does an okay job of conducting heat or electricity. That's why it's used so readily in computer chips. Let's go over one more block. Actually, let's look at phosphorus and sulfur together. Yeah, they're both solids at room temperature, but they're very brittle, and they do not conduct electricity or heat very well. And then we go over to chlorine and argon, and we have gases. Yeah, we have gases. They are nonmetals through and through. In fact, argon is a noble gas. It's got a full octet. It's almost completely unreactive, whereas chlorine, being a halogen, is highly reactive. It's one of the chemicals that are so reactive that you use it as a cleaner in your pool because it's going to kill anything that it comes into contact with. That's also why it's such a good idea that you shower after you take a swim to try to rinse all that chlorine off so it doesn't continue to kill your skin. And so we see... to tie it back to D block elements, when you look at D block, the first D block element, scandium, and then you look all the way to the right at zinc, okay, the other end of the D block, we see not a huge amount of variation in properties, even though you moved 10 groups. Once you get into the P block, you see huge variations in properties when you move even one group over, from aluminum to silicon, from silicon to phosphorus, or from sulfur to chlorine. You're seeing a huge change in properties. Now, B says explain. Explain that. The difference is generally attributed to the presence of electrons in the incompletely filled D sublevels in atoms of the D block. So it has to do with the fact that it is the D sublevel that is being filled in D block elements. That's what they're called, D block elements. Okay. Now there are a huge number of elements in the transition metals that kind of break our rules, that kind of subvert the rules, and for good reason. There are energetic reasons why they do that. But because there are so many variations in the rules when it comes to transition metals, we're not going to be asked a whole bunch of questions about those. So this idea, to this extent, will be enough for you for this course.